Hi, I'm Alex Hopkins,
I'm Annaliese.
and we worked on the project Cold Sintering Teaching Old Rocks New Tricks. So the goal of this project is to combine mine's geology and materials engineering expertise to get a better understanding of the calcium carbonate mineral system. So calcium carbonate precipitates in one of two forms, typically those being calcite and aragonite. So for this experiment, we tested on three different substrates, those being alumina, titania, and silica, see what effect those would have on the material that precipitates out. And then we also tested precipitating at various different pHs to see how pH would impact the results. And so we tried the three substrates we did because they have a wide variety of isoelectric points. And then we tried pH because we know that pH has a very significant impact on the solubility of calcite.
For the experiment, we mixed calcium carbonate with deionized water at 95 degrees until the solution was suspended. After this, we let the solutions to nucleate at room temperature, and then we analyzed the samples using an optical microscope in order to identify any polymorphs that formed during the nucleation process. Substrate pellets of alumina, titania, and silica were also added. The alumina and titania pellets were made with a uniaxial press, while the silica was made from fracturing a microscope slide. A similar procedure was also performed using pH as a variable. The calcium carbonate solutions were adjusted to have a pH of 4 to 6 in 0.5 increments using hydrochloric acid. The precipitated powders were then transferred to a microscope slide for imaging. Below are the known images of calcite and aragonite crystals. As you can see, the calcite tends to form in regular rhombs, while the aragonite crystals tend to form in needles. Next, for the results, for the study, we were more interested in the morphology of our samples and the quantitative size, so scale was not a critical factor for our imaging. So the first image on the left is a bright field image of the titania, and as you can see, is marked by red circles are the calcite crystals we saw, and they were fairly large and easy to identify in the titania. So the calcite crystals precipitated pretty well in the titania substrate. On the right of this, you can see the silica substrate, which had much fewer and far smaller calcite crystals. And then the bottom or the middle row to the left, you can see the alumina substrate powder, which there were some calcite crystals that precipitated, but they were much smaller and less numerous than in the titania. And then the next three images are all from the pH solutions of 4, 5, and then 5.5. And as you can see with the images, the pH of 4 has a much larger grain size than 5, and then even 5.5 is finer. So we observed increasing the pH led to a finer average grain size.
And then to explain our results, so we think for the TiO2, one of the reasons that it might form fewer larger crystals is that the isoelectric point of TiO2 is 6.5, which is about the pH of water. And so if the substrate is less charged, it's going to attract the ions that are dissolved less efficiently. And so that means that the more difficult homogeneous nucleation is going to occur. And so there will be fewer crystals. Although one problem with our experiment is that there was some structural failure of the pellets in the solution. And so it can be difficult in the images to determine what is small crystals and what are of the substrate and what is crystals of the precipitate. And so again, for the silica, we noticed that there were much smaller crystals. And one explanation of this might be that because the silica substrate was amorphous, that the number of nucleation sites per unit area could have changed, which might explain why so if there are more substrate sites, there'll be more crystals. And then increasing the pH decreases crystal size because calcite is more soluble in acidic solutions. And so when it's more soluble, the critical radius will be larger. And so any particles that do form will start out larger and therefore grow larger over time. And the next step is to minimize our variations by using pellets that are processed by sintering so they're more dense, and to use single crystal substrates. Thank you very much.
Thank you.